Dear students, in this video we will solve a few numericals based on vapor pressure, ideal and non-ideal solutions, and all the formulas that we have discussed in Raoult's law. So let's come to question number 1. In this we have been given the vapor pressures of methanol and ethanol are given respectively. They have given the values. An ideal solution is formed at the same temperature by mixing 60 gram ethanol and 40 gram methanol. Calculate the total vapor pressure of the solution and mole fraction of methanol in vapor. So firstly we have to calculate total vapor pressure. So for vapor pressure we need the mole fraction of ethanol and methanol, and for mole fraction we need moles. So firstly we will calculate the moles of ethanol. Weight is given as 40 gram, so that is ethanol is given 60 gram, so 60 divided by molar mass of ethanol is 46, that will come out to be 1.304, and number of moles of methanol will be again equal to the weight of the methanol, that is 40 divided by molar mass, that is 32, that will come out to be 1.25. Now we'll find the mole fraction. Suppose we consider this as ethanol as A and this as B, then the mole fraction of ethanol, that is XA, will be equal to 1.304 divided by adding both total moles, so this will come out to be 1.304 plus 1.25, and when you will solve it you will get it as 0.51, and similarly XB will be equal to 1.25 divided by 1.304 plus 1.25, that will be equal to 0.49. So now we have found the mole fraction of both A and B. Now because the solution is ideal, it has been written an ideal solution is formed, so obviously both the components will follow the Raoult's law. So according to Raoult's law, here we will write according to Raoult's law, PA will be equal to PA naught into XA, and PB will be equal to PB naught into XB. Now we will substitute the values here, so it will come out to be PA will be equal to PA naught is given as 44.5 into mole fraction has come out to be 0.51, that will come out to be 22.69 mm. And similarly when we'll calculate PB, that is vapor pressure of B, so in its pure state the PB naught has been given as 88.7, you can see here it is given 88.7, and multiplied by the mole fraction that we have calculated will come out to be 43.46 mm. So total vapor pressure P will be equal to PA plus PB, and that will come out to be 66.15 mm. And now you have to calculate the mole fraction of methanol in the vapor, so that will be equal to partial vapor pressure of methanol divided by total vapor pressure. So that will be equal to PB divided by PA plus PB, that will be equal to methanol vapor pressure has been already given, that is that we have calculated here, 43.46 divided by total vapor pressure, that is 66.15, and that will come out to be 0.657. So these are the two things that has been asked: total vapor pressure and the mole fraction of the methanol. Next we come to the second numerical. Next numerical is cyclohexane and ethanol at a particular temperature wave pressures of 280 and 160 mm respectively. These two liquids having mole fraction 0.32 for cyclohexane are mixed and mixture has total vapor pressure 376 mm. Will the mixture be an ideal solution? So here the mole fraction of cyclohexane has been given. So we will calculate of ethanol by subtracting it from 1, that is 0.68. Now the formula of total vapor pressure is equal to PA naught into XA plus PB naught into XB, and we'll substitute the appropriate values that has been given, that is 280 into 0.32 plus 168 into 0.68, that will come out to be 203.84 mm. Now since this value, calculated value, when you will compare it with the observed vapor pressure, the observed vapor pressure is more than this, so obviously that is a non-ideal solution. You can write here, since the observed vapor pressure is greater than calculated vapor pressure, it is a non-ideal solution showing positive deviation from Raoult's law. Deviation from Raoult's law. Now the next numerical is urea forms an ideal solution in water. Determine vapor pressure of an aqueous solution containing 10% by mass of urea at 40 degrees Celsius, and vapor pressure of water at 40 degrees Celsius has been given. So mass of urea, suppose we consider it as 10 gram. So the mass of water will be 100 minus 10, that is 90 gram. So here the moles of urea, because the mass percentage of urea is given 10%, that means 10 gram of urea is dissolved in 100 gram of solution. So that's why we have taken mass of urea as 10 gram and the mass of water will come out to be 90 gram. Now moles of urea will be 10 upon 60, that will be equal to 0.167, because the molar mass of urea is 60, and moles of water will be 90 divided by 18, that will come out to be 5, and mole fraction of urea will be 0.167 divided by, you will add the total number of moles, and that is 5.167, that will come out to be 0.032. So according to Raoult's law, P naught minus P upon P naught is equal to mole fraction of the solute, that we have read, that is relative lowering of vapor pressure is equal to mole fraction of solute. So here the P naught has been given as 55.3 minus P divided by 55.3, the and mole fraction of solute you have calculated, that is 0.032, and when you will calculate this, P will come out to be 53.5 mm. So this is the vapor pressure of the given solution at 40 degrees Celsius.